Hi, this is lesson 3.5 and 3.6, Scatterplots, line of best fit, and linear regression. So first off, let's start off talking about recursive and explicit formulas for arithmetic sequences. Go ahead and pause your video and see if you can answer the questions below. The recursive formula for the height above the ground of the nth step of stairs is shown as, and they give us the recursive formula in two forms. So this a sub 1 equals 7 would be our first line. And then this second part is a sub n equals a sub n minus 1 plus 4. Okay, that represents the height of the stairs that are shown in this image. Okay, so they want us to take the recursive formula and find any information we can find out about this sequence. Well, the most important one is this a sub 1. A sub 1 equals 7 represents the first term in the sequence. Okay, it also represents the height of the first step. Okay, and a sub n minus 1 just represents the term before. So if I asked you what is the 10th step, this would represent the 9th step, and so on. But in this case, that does not tell us any information because we are talking about the nth step. Okay, and the positive 4 represents our common difference. Okay, and it's also represented sometimes as d equals 4, which is our common difference. So our first step is a large step of 7 inches, but every single step after that represents 4 inches. Now that we have those two pieces, those are the two most important parts, we can take that and write the explicit formula. So the explicit formula starts with a sub n, because we're trying to find the nth term. Then we need to put in our first term, which we know is 7, plus n minus 1, that's a part of the explicit formula, and we need to multiply it times our difference. In this case, our difference is 4. So you could absolutely leave it just like that. Your other options are you can distribute your 4 to everything inside. If we do that, we get a sub n equals 7 plus 4 times n would be 4n. 4 times negative 1 would be negative 4. If you combine like terms, which would be the 7 and the 4, you get 3. So a simplified version of this explicit formula would be 4n plus 3. Okay, either one of those would be acceptable, either the first line here or this last line. Okay, so even though we do have two different kinds of forms, recursive and explicit, they involve the same pieces. One is better than the other for different situations. If you want to know the very next term, then I would go with the recursive formula. If you want to know a term that's further down the line, then I would use the explicit formula. Okay, real quick, something we did not talk about. This is the opposite. So this time we're given the explicit formula and we need to write the recursive formula, okay? So the first thing we want to do is identify the common difference. If we're looking at this, the part that would have represented our D is the part that's with the N. So in this case, our common difference is 1/2. Okay, to find the first term in the sequence, we need to substitute 1 in for n because we want the first term. N is the number of terms. So if we substitute n in, you can see we get 3/2 as our first term. So now we can write the explicit formula, or sorry, recursive formula. So the recursive formula, again, has two lines to it. The first line is going to represent the first term. So let's go ahead and write a sub 1 equals, we figured out that was 3/2. And then our second line is going to be our a sub n. This is going to be the actual formula part of the recursive formula. So we need to know the term before. So we're going to write a sub n minus 1. Remember, that's how we represent the term before. And then we're going to add our common difference to it. Our common difference is positive 1/2. So that's why it's going to be plus 1/2. And this is how you would write the recursive formula. So it's a little bit more work going from recursive to explicit than what we did on the warm-up was explicit to recursive. but it's not difficult. You just recognize what is your common difference, substitute 1 in for n so that way you can find your first term, and then rewrite the recursive formula. In today's lesson, it's actually 2 lessons combined in one. The first part, 3.5, parts of this are going to be a review for you, so we're going to kind of go through it quickly. And then 3.6 is going to represent the new portion of learning. We're going to be talking about line of best fit and how to find linear regression on the calculator. So for today's lesson, you are going to definitely need a piece of paper. You're going to need your graphing calculator, and then you're also going to need the document that talks about how to find line of best fit using Desmos. Both the calculator and that document are in the resource folder. And then I also put the document into our folder for today. So first, let's talk about some vocabulary. So the first thing we want to talk about is what is association or correlation? So these 2 words are used interchangeably. So sometimes they'll say, what is the association of these graphs? Sometimes they'll say, what is the correlation of these graphs? Both of them kind of mean the same thing. So if you look at association and correlation, you see the word relation or relationship. And that's exactly what we're talking about. What is the relationship of x values to y values? So let's look at this first one. We're talking about temperature after sunrise. So as the number of hours after sunrise increases, what's happening to our temperature? Our temperature is also increasing. So for this one, it is called a positive association or a positive correlation. So as your x values are increasing, our y values are also increasing. So therefore it is positive. For the second one, hours after sunset are increasing, but our temperature over time is decreasing. So this is known as a negative correlation. So the relationship is negative, it's going downhill from left to right. So our x values are increasing, right? Time is still increasing across the bottom, but our temperature is decreasing. Okay, so if they are both going up, it's going to be positive. If one's going up while the other one goes down, it's going to be negative. Now this one over here talks about rainfall after sunset. I can't talk today. As the hours after sunset increase, what's happening to the amount of rainfall? Well, are those 2 things related to one another? If I wait till 6 hours after sunset, does that mean that it's going to rain more or less than 2 hours after sunset? Those 2 things have nothing to do with each other, rainfall and sunsets. So this one has no correlation. So they have nothing to do with each other. These ones are usually the easier ones to find. So go ahead and pause your video. I would like you to describe the type of association with these scatter plots. So remember, your possibilities are positive, negative, and no correlation or no association. All right, so for the first one, you can see there is a trend. Most of our dots are increasing from left to right. So our x values are increasing and so are our y values. So this one has a positive correlation. Okay, B, on the other hand, like I wouldn't be able to draw a line. Like this one, I can kind of draw a line, see the trend. This one, there is no line that I could draw. They're kind of all over the place. So this one has no correlation or no association. Okay, you can use those interchangeably. So correlation, association. All right, so here are some real life examples of positive and negative correlation. So the first one says the amount of gasoline in your car and the number of miles driven. So what happens to the amount of gas in your car as you drive more miles? Well, as you drive more miles, the miles increase, but the gas in your car is decreasing. So this has negative correlation. Okay, this one, a height of a candle and the amount of time a candle burns. So as the time increases, what happens to the height of your candle? It decreases. So you have one of each, one increasing while one decreases. That is also negative correlation. All right, the number of tooth cavities and the amount of candy consumed daily. So as you consume more candy, what's happening to the number of cavities that you possibly have? Well, they're both increasing. So this is positive correlation. The number of pages in a book and the width of a book. So the wider the book, the more pages there are. That is both increasing. So that is positive correlation. Okay, the size of a dog and the amount of dog food needed. So the bigger the dog, the more dog food you need. So they both are increasing. That is positive correlation. All right, the smaller the dog, the less dog food you need. Okay, the height of a child and the age of a child. So as they get older, what typically happens to the height of children? Okay, children don't usually shrink, so they're usually also increasing in their height. So this is also considered positive correlation, height and age of a child. The number of absences from school a student has and their grade point average. So what do you think is going to happen to a student's grade point average as the number of absences increase? Of course, their grade point average is going to go down. So this is an example of negative correlation. Okay, absences are increasing, the grade point average is decreasing. And this last one is a little hard to see. Let me see if I can move it to the front for us so we can see it. The number of overtime hours worked and the amount paid. So the more hours you work of overtime, the more you're going to get paid. They're both increasing, so this is also going to be considered positive correlation. So you have a lot of different real-life examples that show you both positive and negative correlation. Let me see if I can slide that over so we can see this one goes along with the positives as well. All right, now I have two examples that are no correlation. All right, the weight and birth year of a child. Okay, do they have anything to do with each other? So is a child who was born in 2007 going to weigh more or less than a kid who's born in 2020? No, the weight and the birth year have nothing to do with each other. They have no correlation or no association. The cost of college tuition and the school colors. It's not like they're going to charge you more if your school colors are yellow and gold versus purple and gold. Okay, so again, those two things have nothing to do with each other. And they're usually the silly ones, like the number of sunglasses sold to the number of siblings you have. Again, two things that have nothing to do with each other. They're very easy to pick out. All right, so what is a trend line? A trend line models the data in a scatter plot by showing the general possible direction of the data. A trend line fits the data as close as possible. So in this example here, we have electric hybrid cars sold. So across the bottom, I believe this is time, and then we have our numbers of cars sold. So do you see how the blue line is our trend line? Now, the trend line does not always go through every single point. It is a straight line, and you want it to go through the center of your data. So sometimes it may go through multiple points, sometimes it may not, and that's okay. It just fits your data the best. Okay? So in this one, it says sketch the trend line for the data, which we've already done. Step 2 says write the equation for this trend line. So to write an equation, we have 2 points. They gave us 250 and 16,500. We can use that information to write our trend line. So let's think about what we talked about in our last unit with linear equations. I'm just going to write the 2 points here, 250, because that was my first point, and my second point is 16,500. The first thing I need to find is my slope. So I'm going to use my equation, x1, y1, x2, and y2. So we're going to have y2 minus y1 over x2 minus x1. Make sure that your y values are your numerator and your x values are your denominator. That's where a lot of people mix this up. So y2 is 500 minus my y1 is 50 over my x2 is 16 and my x1 is 2. So 500 minus 50 is 450. 16 minus 2 is 14. And if I grab my calculator and I type in 450 divided by 14, I get a slope of roughly 32, and we'll say 32.14. Okay. And so this represents the number of cars, thousands of cars sold per year. Okay. Because you look at our label here, this is in thousands. So 32,000 cars are sold per year. Now, in order to write the equation, an equation has a slope and a y-intercept. So we can't really tell the y-intercept because it doesn't really look like it goes through the origin. So what we're going to do is we're going to pick one of our 2 points. I'm going to choose the smaller of the two. I'm going to choose the 250. And we're going to substitute that into our equation. You can use point slope if you would like, or you can use the slope-intercept form. So I'm going to say 50 equals, I thought I changed colors. Let's try that again. 50 equals, M is 32.14. My X value is 2 plus B. Okay, so if I take my 32.14 and I multiply it by 2, I get 64.28. All right, and if I want to solve for this B value here, make sure that it looks like a B and not a 6, I need to subtract 64.28 from both sides. Okay, so I'm going to go to my calculator. 50 minus 64.28. And we get a B that equals negative 14.28. Now that we have the slope and the y-intercept, now we should be able to write our equation in slope-intercept form. So we can say y equals, my slope we said was 32.14, x, and then my y-intercept is negative 14.28. So that is the equation for this blue line. Does that data fit exactly? Maybe not, but it's pretty close because we see that all of our dots are kind of scattered around that. Some are higher, some are lower, but the general trend tells us that this would be the equation for that line. All right, so let's take a look at this one. So this one, we want to make a scatter plot and draw the trend line just like we did before. The table shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend line continues, how long would it take for a 100 megabyte file on the internet speed of 75 kilobytes per second? So we see our kilobytes, our internet speed is on top, and then the time it takes to download is on the bottom, okay, in minutes. So it says make a scatter plot of the data and sketch the trend line. So we're going to go ahead and do that for you because obviously virtually it's a little hard to graph this. So they did the scatter plot. They plotted each one of these ordered pairs. There are 6 of them, so you see 6 dots. They drew the trend line, and then they noticed that there are 2 points on the trend line. So we have 46 and 55.4. So the next step would be to find the equation of that trend line. So go ahead and pause your video. I would like you to find the slope between those 2 points, find your y-intercept, and write your equation of the line. All right, so let's take a look at this. So if I take my equation and I do my y2 minus y1, x2 minus x1, I get 4 minus 6 over 55 minus 40. So we have 4 minus 6 is negative 2. 55 minus 40 is 15. Okay, and then if I simplify that in my calculator, negative 2 divided by 15, we're going to keep it as a decimal. It is negative 0.13 repeating. So we can say m equals negative 0.13, and we'll just leave it like that. Okay. All right, now I need to find my y-intercept. So I'm going to take my first point and I'm going to substitute it in. So let me slide down a little bit so you guys can see. So my y value is 6. My m is negative 0.13. My x is 40 plus b. Well, if I take this number times 40, I get negative 5.5. Or sorry, negative 5.2. All right, so I have to add 5.2 to both sides in order to get the b by itself. So 6 and plus 5.5 is 11.2 is my b. So my equation of my line, if I write it out, would be y equals my slope of negative 0.13, x, and then a positive 11.2 would be my y-intercept. So looking at this makes sense because I can see my slope is negative, so that number definitely should be negative. And I can see 11.2 would be up here somewhere, which looks like it's in line with that graph. All right, our final step is to use the equation of the linear model to find the value that corresponds with x equals 75. So if you're looking at our graph up here, our table, it doesn't even go up that high, but we can use our equation to predict how long it would take to download a 75 kilobyte file. So to do this, we're going to substitute our x for 75. So negative 0.13 times 75 plus 11.2. So if I go ahead and do all of this in my calculator at one time, so I'm going to type in negative 0.13 times 75 plus 11.2, and I get y equals 1.45. Okay, so this represents minutes, so it's going to take almost a minute and a half for a file that's 75 kilobytes to download. So this is our estimate. Now, it may take more or it may take less. Again, our trend line is just making a prediction of what we think is going to happen. All right, so now we get into some of the new stuff. Now we're going to talk about analyzing line of best fit. And this is where the fun stuff comes in. Okay, so what we're going to talk about is we're going to talk about linear regression and line of best fit. So you already know what the line of best fit is. So now we're going to talk about actually finding it on there. So there is the file on Desmos. I'm going to pull it up right now. This is what your file looks like. I created it is step-by-step directions on how to find line of best fit using the Desmos calculator. There is a link to it here at the top, but it is also in the resource folder for you. This is something that you need to become comfortable with because you will see line of best fit on MCAP. Okay, and the calculator that you will have available on the screen will be this graphing calculator. Okay, so let me see real quick. Before we start graphing, I would like to talk about what linear regression means. Okay, so linear regression is the method we use to find that line of best fit. Okay, and there's a thing called the correlation coefficient. It is represented by the letter R. And it measures two things. It measures the direction and the strength of the correlation between the two variables. So between our X and our Y. And we kind of have this little diagram down here. So if the correlation coefficient R is 0, that means that there is no correlation between the two things. So that was our situation when we had cost of tuition and high school colors or college colors have no correlation. Their correlation coefficient would be 0. Okay, if you have a strong positive correlation where everything is increasing, then you're going to have a number closer to the positive 1. If you have a strong negative, it's going to be closer to negative 1. So all of your R values will be in between negative 1 and positive 1. So here are some examples of what they would look like, and there are values. So you can see this one they drew the trend line. Our R value is 0.984. That is really, really close to 1, so that tells me that it has a very strong positive correlation. Okay, this one here is negative 0.284. It's on the negative side, but it's really close to 0. So I can also tell by the points, our numbers are all scattered all over the place. There really is no correlation for these ones. Okay, and if you look at this one, our number is negative 0.995. That's very, very close to negative 1, so it has a very strong negative correlation. So if you kind of imagine, how close are your dots to the line? The closer they are to a perfectly straight line, the stronger correlation is. The more scattered they are, the weaker the correlation is. Okay, and the reason why I bring this up is because when we are finding our line of best fit, you're going to see the R value on the calculator, and I want you to know what that represents. Okay, so we are going to find the linear regression for this one here. So I'm going to go ahead and skip forward real quick. I'm going to grab my graph and calculator and come back, and I'm going to show you how we're going to do this. So line of best fit. Okay, and again, all these instructions are on that document for you. Actually, let me go back and show you real quick. In the resource folder, there's the graphing calculator. There is the document how to find line of best fit on Desmos. Now, when you open the graphing calculator, it will open up inside of Schoology. If you would like it to come into its own tab, in the top right corner, you see this little pop-out button, and that will take it from inside Schoology where it lives to a new tab for you. And that might be helpful so you can still navigate within Schoology and other tabs, and you can move your calculator around. Okay, so I'm gonna go back, and is this the same one we're doing? Yep, it's the same one, so we can actually stay here. I'm gonna open up my Desmos calculator. Now, it looks a little bit different than the TI-84s that we use in school, but this is where you're gonna put your equations, and then we have other tools. This is our graph. We have some tools over here. We can zoom in and out if we want to. And the very first thing our document tells us to do, it says add a table by clicking the plus in the top left corner. Okay, so that's what I'm going to go ahead and do right now. In the top left corner here, I see the plus button. If I click add, I want to add a table. Okay, and you can see I have my X values and my Y values. So I'm going to go ahead and just move this around a little bit so we can see. I might have to minimize it a little bit because I want to be able to see what values we are putting in our calculator. All right, so I'm going to put all my X's in the first column. So I have 1, hit enter, 2, 5, 8. Whoops, there was no 6. I can go back and fix that. 8, 9, and 17. Okay, and then I'm going to go over here and click on my Y's, and I have to make sure that the Y's match up with the correct X's. So we have 30, 55, 75, 120, 145, and 250. Okay. Now, another thing you want to definitely recognize is you want to make sure that you have the same number of X's and Y's. There's no extras at the bottom, so you want them to line up. Okay, if I go ahead and hit enter, or click off of there, you can't see all of my points because they are kind of spread out a little bit. So in order to see where these points are on my graph, I'm going to go to this wrench where it says graph settings, and I'm going to look at my X values and my Y values, and I'm going to adjust these numbers a little bit. So looking at my X values, my lowest one is 1. I want to go a little bit below that, so I'm going to change this to 0. And I'm going to look for my maximum X value. So this is my domain. My biggest one is 17. I can go a little bit bigger. I'm going to even go up to 20. You want to be above and below what your X values are. And then we're going to do the same thing for our Ys. So my lowest Y is 30. So I'm going to go to 25. And my highest Y over here is 250. I want to go a little bit above that. So I'm going to go to 300. And now, I close that and I zoom out a little bit. You can kind of see there are my 6 points. All right, so now I want to create a line of best fit. So if you go back to your document, again, it shows you right here how to fill in your tables, how to adjust your window. So you can see We're in step 4 where it says type in this y1 and then this little squiggly line, mx1 plus b. Okay, and that's very important. If you need to, you can copy and paste it. So in our calculator, on this next line, we're going to type y1. The squiggly is shift and then it's to the left of your 1. mx1 plus b. And you would notice that it puts in my line of best fit for me. Okay. It also gives me a lot of information here. I can tell, look, there's my slope, my m, there's my b. So I can write the equation y equals mx plus b. And then it also gives me my correlation coefficient. And the one we're going to look at is this one right here that just says r. Don't worry about r squared. So I can tell from this 0.9955, that is very close to positive 1. So this graph has a very strong positive correlation. All right, so if I go back to my thing here and I see what they want me to find, okay, they want me to find the line of best fit, the equation. Well, we kind of found that. It's going to be y equals. And then from the graph, we can see my m is 13.55, so I can actually round up to 13.6. X, and then my b value, my y-intercept, looks like it is 17.58, so I can say 17.6. Right? So I get a lot of information. I get my actual equation for my line of best fit, and I also can tell my R value, which is a strong positive correlation. Okay, what I would like you to do is pause the video and see if you can find the line of best fit for this one. Again, using your graphing calculator. If you would like to clear out your graphing calculator, you can just hit the X's and you can start fresh. All right, so we have these values here. I'm going to go ahead and create a new table by hitting the plus sign. And I'm going to add my values in. So my values go from 1, 2, 4, 5, 7, 9, okay, 8, 9. So it's not necessarily in order. It is, but we skip around some. I will tell you 99% of the time when students have difficulty finding the line of best fit on the calculator, whether it be the ones in school or this Desmos one, it's because it was user error typing in your numbers. So my Y values, 5.4, 6.1, 8.1, 8.5, 10.3, 10.9, 11.5. Okay, I'm double checking to make sure I have the same number of X and Y values, which I do. I can see a little bit of my points here, but I want to adjust my window just so it fits a little bit better. My lowest one is 1, so I'm probably going to go down, change my X to 0. My highest is 9, so you can probably go up to 10. You can go as low or as high as you want. Just make sure it's a little bit below and a little bit above. For the Y's, my lowest value looks like 5.4, so I'm going to go down to 5. And my highest is 11.5. I'm going to go up to 12. Okay, and if you notice, it looked like it was like scrunched like horizontal line at first, but that was just because of the scale. Now that I've changed my window to fit my data a little bit better, I can tell that it actually has a positive slope. Okay, so now I need my line of best fit. So remember, it's y1 squiggly mx1 plus b. Okay, and this is a unique equation to the Desmos calculator. All right, so looking at this, I can tell exactly what my slope and my y-intercept are, and I can tell my R value. Again, my R value is very close to positive 1, so this has a strong positive correlation. So I can go ahead and transfer this over to my document. So I would say y equals 0.77, or you can say 0.78 x plus 4.7. Okay, and that would be your equation you would put here. All right, so this next one, we're going to do one more kind of together. Let me make sure, one more together before you guys try your exit ticket. There is one more bit of data that I need to talk about that has some vocabulary words. You may have seen them on the one screen, but we have two words. Let me go back so you can see what they look like. It was this one here, I believe. Interpolation and extrapolation. So interpolation, extrapolation. I'm going to type them here. Okay. What these two things mean, if you are asked to interpolate or write an interpolation of data, that means that they are asking you to find a point that is somewhere inside the data that we have. So like, for example, in this one here, we're talking about years and price of milk. They may say, how much was the price of milk 7 years after 1995? Well, 7 years is not on our table, but it's within our data. So that is interpolation. If they say extrapolation, that is extra. It's outside of our data. So an example of that, they may say, find the 30 years after 1995. Well, obviously 30 is not anywhere close to our numbers we have here. It's something outside of our data that we would have to find. Okay, so I just want to mention those two vocabulary words because sometimes you do see those. All right, so for this one, I would like you to pause your video and we're going to answer these 5 questions about our data. You may have to create a scatter plot and you have to create a line of best fit so you can figure out your correlation coefficient. All right, so let's go ahead and talk about this one. So now that I have my data, I'm going to go ahead and clear my graphs out because we want brand new data. Okay, and looking at my table, I'm going to put my X values in. All right, and then I'm going to go over and put my Y values in that match. And you don't have to put in the dollar signs at all when you're talking about these. And being very careful to make sure that I'm typing in my values exactly how I see them. If I make one little mistake, it's going to change my data. All right, so I have the same number of X's and Y's. I'm going to go ahead and type in that formula that's going to give me my line of best fit. And believe it or not, guys, this formula that's here that goes into Desmos, the steps are a lot easier than if we were using a TI-83 or 84 calculator. Right, MX1 plus B. If we don't put that plus B on there, we're not going to get all of the data that we want. Okay, so it says, does the data on the scatter plot have positive, negative, or no correlation? Well, right now I can't see my data. I can kind of make a guess, but I need to change my window so that way I can see it. So I'm going to go from 0 years to, let's go to 20 years on my X. And then for money, let's go from $2 to $4. Okay, so now I can see my data a little bit better. Okay, looking at this, I can tell that it's increasing from left to right, so it has positive correlation. And looking at my R value, I can tell it's a strong positive. So when it comes to this one here, does the data on the scatter plot have positive, negative, or no correlation? It has positive. Okay, what is the correlation coefficient? Well, that is our R value. R equals, let's see what that was. I can't remember exactly what it was. 0.9797. You can round it if you want to. And what does it tell us about the data? It is a strong positive correlation. Okay, so what that tells us is that the cost of milk and the time in years since 1995 are strongly related to each other. okay, in a positive fashion. As the years increase, the price of the milk is also increasing. Okay, calculate the line of best fit for this data. Well, we did that. Oh, the calculator did it for us. So we have our M and our B, and I'm going to go ahead and round this to 6 cents and this one to 2.52. So we have Y equals 0.06x plus 2.52. Okay, so looking at this formula, what does this mean? So the 6 cents is our slope. So that means for every 1 year, the price of milk was increasing by 6 cents. And the 252 is our starting amount. So that means at 1995, year zero, the cost of the milk was about $2.52. Okay, so now this one says use the equation to predict the cost of milk in 2010. So is the cost of milk in 2010 going to be interpolation or extrapolation? Is it inside our data or is it outside of our data? Well, looking at our table, 10 would be right here. It is inside our data, so this would be an example of interpolation. Okay, inside, interpolate. Okay, so we're not going to use our chart. We kind of know it's going to be in between these two. We're going to use the equation to fill this out. So let me go ahead and grab my pen. We need to substitute a number in for X. Now it says for 2010. This is measuring years since 1995. So how many years after 1995 was 2010? Okay, well, 1995, if I add 5 years, that gives me 2000, and I have to add another 10. So really, this is 15. Oops. So in this case, X equals 15. So actually, it's not 10 right here. It's still interpolation. It's actually 15 that we're looking at up here. Okay, I made a mistake. It's not, because this isn't 1 year to 9 years. These are 1 year after 1995 and so on. So we're looking for the 15th year after 1995. So I'm going to go ahead and substitute 15 in for my equation. Y equals 0.06 times 15 plus $2.52. This should be easy because it's all on one side, so I should be able to go ahead and put it all in my calculator at one time. 0.06 times 15 plus $2.52. So we get $3.42. Okay, so that is what we estimate the cost to be in 2010. So looking at our data, does $3.42 kind of fit in between these two? Yes. Okay, so we can kind of make that prediction. So the whole point of line of best fit and linear regression are to make predictions about our data. Okay, so here is your exit ticket. It is on Schoology. The first thing you're going to do is you're going to take your table and you're going to calculate the linear regression equation. So I want this written in y equals mx plus b form. Okay, you're going to fill in your m and your b. Once you have done that, you need to tell me what is the slope, what is the y-intercept, and what do they mean. So if you need to, go back to the milk problem we just did and look at what the 6 cents represented and what the $2.52 represented. Okay, that will help you with this one. If you have any questions, I am available in our virtual classroom. So stop on by. Let me know if you have any questions about how to use the calculator and how to calculate linear regression.